Okay, so in this video, we will introduce the concept of higher derivatives. And as you'll see, the idea is very simple. So let's approach this first with an example. Consider the function y equals to x to the 4. Well, y is a function of x, so we can find its derivative with respect to x. So dy dx. And of course, from the power rule, the derivative of x to the 4 is 4x cubed. And now look at the derivative of y with respect to x. 4x cubed is also a function of x. And you say, well, why not take the derivative of this function, therefore the derivative of the derivative? So we differentiate with respect to x our first derivative, dy over dx. Well, this is the derivative of our derivative, but dy over dx is simply 4x cubed. 4 is a constant multiple, so it just stays there, times the derivative of x cubed by the power rule once again gives us 3x squared. But 4 times 3 is 12, and so we get 12x squared. And you say, well, interesting. The derivative of the derivative is also a function of x, and it is also differentiable. So why not differentiate again? Let's take the derivative of the derivative of the derivative of y. But as we have just found, the derivative of the derivative is the simple function of x, 12x squared. So we simply want to differentiate 12x squared. Well, 12 is a constant multiple, it stays there, times the derivative of x squared by the power rule once again is 2x, which gives us 24x, which also is a function of x. So we could differentiate again and again and again. And it's the idea of higher derivative. Every time you differentiate, if the derivative is a function of x, you can differentiate again and again and again, as long as the function you obtain is differentiable. Well, you might imagine that if we want to say let's differentiate a function 20 times, we do not want to write d over dx of d over dx of d over dx of the function 20 times. This is taking up way too much space and way too long to write. So let's look for a very compact notation, way of saying we want to differentiate the function y n times. And so d over dx says take the derivative of, take the derivative, dot dot dot, take the derivative. So here we're saying differentiate n times. So n could be any positive integer. We could differentiate the original function 5 times, 1,000,000 times, as long as every step of the way the function obtained is differentiable. We'll simply denote this by d to the n, if you think of it, d n times d to the n over dx 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 n times, so dx to the n. So this is a notational tool to say we want to take the derivative with respect to x of the function at front n times. So instead of writing, say if n was 10, d over dx 10 times, you simply write d to the 10 over dx to the 10. So let's now give a definition of what we call the nth derivative, which is simply take the derivative of the function n times. And you'll see we'll have also a notation that is very close to this. There will be equivalent, so you can use either one. So the nth derivative Of course, here implicitly n is a non-negative integer, So the nth derivative of the function y equals f of x is denoted and defined by so here's several ways of denoting it. You can write y with, in brackets, an exponent n. So this doesn't mean the nth power of y. If we meant the nth power of y, it would be y to the n, no brackets. But when you write the exponent in square brackets, it means the nth derivative of the function y, which means differentiate y n times. Of course, you could write instead of y f, so you could do the same thing. F exponent in square round brackets n, differentiate f n times as a function of x. You can also write, of course, the derivative with this notation. So differentiate with respect to x n times the function y, which is now defined by, as we've said, taking the derivative of the function n times. And that's it. So the definition, the nth derivative of the function, means differentiate with respect to x, the function n consecutive times. This is too long to write, so we use either this notation or this one or this one. All three are equivalent. And this is how you define the nth derivative. Of course, if n was 0, then if you differentiate the function 0 times, you get back the function. And so just as an aside, y to the 0 is simply y. Don't differentiate, you get the function back. And that's it.